Okay, so now let's look at a recursive problem of finding time complexity. So let's have this code over here and let's take this as a problem. So try to think about this code which finds a to the power b. So this code is nothing but finding a to the power b. Okay, a to the power b. How do you find out the time complexity of this? Okay. So what is the time complexity of this? Think about the problem a bit. This is this this is a simple implementation of finding a to the power b. Okay, so for this you need to understand that there are some recursive calls, right? And this a over in this recursive calls is not changing. So this is just a static member and like this is not gonna change in the recursion. Only this b is getting halved every time, right? So we discussed master theorem for recursion, right? So we have a, b and b gets halved. So let's suppose t of n denote the time taken by this power for some particular n. Like let's call this b, t of b. Uh, let's say t of b is the time taken by power a comma b. Okay, the number of instructions kind of thing. Okay, so t of b will be equal to, this is order 1, this is order 1, this is order 1, this is some recursive definition, right? So there are two recursive calls, so 2 times t of b by 2 because the instance of b is getting halved, right? Plus some order 1, right? Some order 1 stuff over here. Now once we have this, how do we find the complexity? Master theorem, right? We discussed that this form is something that master theorem can solve. So for over here, a is equal to 2, b is equal to 2, c is equal to order 1, log of b base a base b n to the power this is equal to n to the power log of 2 2, which is equal to n, right? So this part is giving you order n, this is giving you order 1, so max you take the bigger one of them, right? This one. So this code is nothing but order n, right? So this finds a to the power b in order n time. Okay. So now we try to do just a single change in this code. Okay, let's say we just do this. This is declared, and then instead of calling this power twice, what we do is that we just multiply temp with itself, right? And we don't want to declare it again, so temp multiplied, it's just simple as temp is getting squared. Okay, now what's the time complexity of this code? Does something change? Earlier it was order n. Does the change in writing the code a bit change our complexity? Let's look into that. So again now we have the same idea of t of b because it's getting halved only. Okay, so now there is only one recursive call and everything is order 1. So 1 times t of b by 2 plus order 1, right? And now if you think about this, a is equal to 1, b is equal to 2, c is equal to 1, n to the power log base b a is equal to n to the power log base b1, sorry, 2 1. Okay, and this would be n to the power 0, which is equal to 1, right? Now this is order 1 and c is already order 1, right? So these two are same. So when they are same, we know that we get a log n extra in master theorem. So this becomes order log n finally. So this code over here is order log n. Okay, and this is a really nice application of changing the code a bit and finding out power of a to the power b in order log n. Okay. So this is how you deduce time complexity of such recursive functions. So that's all for this video. See you in the next one.